Today we're going to start our new unit, which is on transformations. Now when we talk about transformations, we're talking about taking some sort of geometric object and changing it in some way, transforming it in some way. And today we're going to be talking about how we can transform something algebraically and geometrically. So what does this mean? Well, when we're talking about changing something algebraically, we mean that we are going to use some sort of algebraic rule to transform the points of the pre-image, which is the original image, into the points of the image, the resulting image. Now, when we're talking geometrically, we will be graphing the pre-image and the image using a coordinate plane. So we'll be able to see, after we've done some algebraic transformation, what that actually looks like geometrically when we graph it. So let's talk about the algebraic rules. So for all transformations, there are algebraic rules to find points. The rules will be given something like this. So on the left there you have the original points x comma y, and then there will be an arrow, and then on the right it will tell you what it transforms into. So in this case, both x and y become the opposite. So it becomes negative x, negative y. So each rule tells you what to do with the x and the y values from the pre-image to create the image. You'll use the rule for each transformation to find a new point for each point that's in the pre-image. Okay, so let's actually go through all the different rules. So the first type of transformation we're going to see is what we call a translation. So the algebraic rule for a translation is given by this. So x comma y, which is the original point, becomes x plus or minus a and y plus or minus b. Now what are a and b? Well, a would stand for a shift to the right or to the left. If it's positive, if a is positive, so you have x plus a, it will be a shift to the right. If you have x minus a, so if it's negative, it means it's going to be a shift to the left. Now b stands for a shift up or down. If you have y plus b, so if it's positive, it means it's going to shift up. And if you have y minus b, this means it's going to shift down. Let's take a look at an example of a translation. So figure ABCD has the vertices A at 1, 2, B, 3, 3, C, 4, negative 1, and D, 1, negative 2. Sketch ABCD and its image after a translation left 4 and down 2. So for the first step, we're going to first write down the algebraic rule. In this case, a translation to the left 4 would mean we have x minus 4. And a shift down 2 means we have y minus 2. So x comma y becomes x minus 4 and y minus 2. Now for the second step, I'm going to list all the points of the pre-image, and then I'm going to transform each of those points to get the new point. So let's start with A. So A was originally at 1, 2. And for the new point, I'm going to use a little apostrophe after the A. This is read as A prime. So A prime has coordinates at, well, how do you find those? You take 1 and you subtract 4, and that gives you negative 3. You take 2, subtract 2, and you get 0. All right, for the next one, we have B at 3, 3. We do 3 minus 4, which gives us negative 1, and 3 minus 2, which gives us 1. So B prime is at negative 1, 1. Okay, and then C, we have 4, negative 1. So 4 minus 4 is 0, and negative 1 minus 2 is negative 3. So that means C prime is at 0, negative 3. And then the last point, we have D at 1, negative 2. So 1 minus 4 is negative 3, and negative 2 minus 2 is negative 4. So D prime is at negative 3, negative 4. And then the last step is to graph the pre-image and the image. So because it said to sketch ABCD, which is the original, and its image, which means after the transformation. So let's go ahead and graph ABCD. So that's 1, 2, 3, 3, 4, -1, and 1, -2. I'm going to connect all of those points, so from A to B to C to D. And then we graph all the points of the image, so -3, 0, -1, 1, 0, -3, and -3, -4. And again, connect those. It would be helpful to also actually write out what those vertices are, so A, B, C, and D, and in the image, that's A prime, B prime, C prime, and D prime. So now that we've talked about translations, we're going to go on to our next type of transformation, which is a reflection. Now there are 3 different types of reflections. First, you could have a reflection over the x-axis. The rule for that would be xy becomes x negative y. Then we'll reflect over the y-axis. So x comma y becomes negative x comma y. And then the third type of reflection is a reflection over the line y equals x. In this case, the rule is that x and y just switch, so it becomes y comma x. Let's go ahead and take a look at example 2. Figure MILK has the vertices M, 1, 1, I at -4, 3, L at -2, 5, and K at 3, 4. Sketch MILK and its image after a reflection in the x-axis. Alright, so because it tells us that the transformation is a reflection in the x-axis, we can start by writing down the rule. So x comma y is x comma negative y. This means that x is going to stay the same, but your y-coordinate will become the opposite. Now let's go ahead and apply this rule for each point. So 1 comma 1 becomes 1 comma -1. So the x-coordinate stays the same, and the y-coordinate becomes the opposite. -4, 3 becomes -4, -3. -2, 5 becomes -2, -5. 3, 4 becomes 3, -4. Now we're ready to graph the pre-image and the image. So we have 1, 1, -4, 3, -2, 5, and 3, 4. So that's MILK. And then we'll graph the image, and that would be 1, -1, -4, -3, -2, -5, and 3, -4. And you can see here, after I've labeled this here, how exactly we have reflected our original image, our pre-image, to become the image. And the third type of transformation is a rotation. Now there are 3 different types of rotations. Note that they're all going to move in the counterclockwise direction around the point 0, 0. So a rotation of 90 degrees is going to be x comma y becomes -y comma x. So here, your y-coordinate, you take the opposite of that, and that becomes your x-coordinate. And then take your x-coordinate, and that becomes your y-coordinate. And that's a rotation of 90 degrees. Next, a rotation of 180 degrees. So this is where x comma y becomes -x, -y. So both the x and the y coordinates become the opposite. And the third type of rotation is a rotation of 270 degrees. This is where x comma y becomes y comma -x. So your y coordinate becomes your x coordinate, and then the opposite of your x coordinate becomes your y coordinate. Let's take a look at example 3. So figure DOG has the vertices D, 5, -2, O, 9, -4, and G, 5, -7. Sketch DOG and its image after a rotation of 90 degrees. Let's start out by writing the algebraic rule. So this is a rotation of 90 degrees. So x comma y becomes negative y comma x. Next, we're going to list all the points, and we're going to apply this rule. So let's start with 5, negative 2. So 5, negative 2, you take the opposite of y, which is positive 2, and that becomes your new x-coordinate. And then take your x-coordinate, and that becomes your y-coordinate. So this becomes 2, comma 5. Let's continue. So the next is 9, negative 4. So applying the rule would give us positive 4 for our x-coordinate, and then 9 for our y-coordinate. And the last point, 5, negative 7, that becomes positive 7, comma 5. And now we can graph the pre-image and the image. So we have DOG at 5, negative 2, 9, negative 4, and 5, negative 7. And then we'll go ahead and graph our image. That would be at 2, 5, 4, 9, and 7, 5. And now let's go ahead and label. And we can see after we label how we have rotated this figure DOG 90 degrees counterclockwise about the origin 0, 0. You can imagine if this blue figure were attached to the origin by a string, and you simply rotated around the origin along with that string 90 degrees counterclockwise, and you would end up with that red figure. So today we talked about 3 different types of transformations. We talked about translations, so shifting left, right, up, or down. We talked about reflections, and we talked about rotations. For each of those, there were rules, and for reflections and rotations, there were 3 different types each. And then all we had to do was apply those rules, those algebraic rules, and then we were able to see geometrically how the image was transformed.